So in this video, we're going to talk about what we call parent functions. And parent functions are the basis for all the other functions. So by identifying the general shape of a function, it'll tell you a lot. And here we have a couple of common functions that we deal with. And you can create the graph for any of these functions by looking at its equation and then plugging in values for the equation. For instance, f of x equals x. Well, remember, f of x is just y. So we literally have a table we can make for this that says when y equals x, we could do just take some x and y values. So for instance, when x is 0, it looks like y will be 0. When x is 1, it looks like y is also 1. When x is 2, it looks like y will be 2, and so forth. And you can also go the other way. When x is -1, y should also be -1. Again, that's because x equals y. Here, we have the absolute value function. And the absolute value function makes a common V shape. Absolute value is the difference from 0, or the distance from 0. And the distance is always positive. Henceforth, y, this function will always sit above this line right here, this value right here. The y values will always be positive. So when you look at this one, for instance, you get f of x is equal to the absolute value of x. So any number you plug into the absolute value sign inside of here will become positive. So if you make another table again, if you plug in -1, well, f of -1, plug in -1 here, you're going to get a +1. And that's why you get this right here. F of -2 is a +2. That's why you get this right here. F of 0 is just 0. F of 1, plug it in, you're going to get a +1. And then f of 2, plug it in, you're going to get a +2. And from this, we can see that our domain of this function also, remember our domain goes from left to right. And the domain of this function looks like it's going to be, on the left hand, it goes to all reals. On the right hand, it goes to all reals. So that's just -infinity to +infinity. And the range of the function, well, because the y values can never be negative of this function, the range will never go below 0. So we're going to include 0 and go to +infinity on the y. And so we'll do that for every function. The quadratic function as well makes the U shape. So if you look at your quadratic function, again, just take values and plug in. Normally plug in -2 for x, -1, 0, 1, and 2 to get the general shape. And all you're doing is you're plugging in -2 right here into this equation, x squared. Well, -2 squared is a +4. -1 squared is a +1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. And so when you do this, if you plot these points, 0, 0, 1, 1, -1, 1, 2, 4, -2, 4. That's why you get your U shape here. And this U shape, again, you can find the domain and range. The domain, again, extends all the way to -infinity to +infinity. And the range will be, again, you can't go below, you'll never get a negative value because squares are going to make everything positive. So again, you're going to include 0 to infinity. And so you can look at all these different common shapes, and from there, you can get, and from just generating tables, you can actually get these shapes. And the idea here is to look at any function that's given to you and be able to identify where its parent is, because the parent holds the domain and range of each function. These rarely change depending upon the transformations that we're going to talk about in our next unit. So if you look here, here are some examples. When I look at this, you need to be able to identify every one of these different functions that are on this page just by looking at the graph. So if we look at this function right here, this function has been transformed. And we want to see what function does it look like. Well, we can see the curve in the function. And when you look here at this, then we come up here, the only function that has a curve in it is this square root function right here. And so this function itself is the square root function. So the parent for this is going to be the square root. And notice the square root function domain on this particular function. Again, we talked about domains of square roots. Square roots can't be negative. We've shifted this so here, the smallest value is 2, and it's going to infinity. And on the range, we can't go below 0 here. So again, we're going to go 0 to infinity looking at the graph. On the next graph, notice this is the V shape. And on your V shape, we've shifted it again. But you're shifting your V and you've did some other things to it. But this V shape again is called the absolute value graph. So the parent here is absolute value. And again, we can calculate the domain and range. The domain of every absolute value function is all real numbers. The range, the lowest point on the graph here, the Y value is 0. And we're going to include that. And it's going to go up to infinity. And on this last graph, again, we're looking at it. We see that this is the quadratic function that's been shifted up. The domain of every quadratic is negative infinity to positive infinity. And the range of this quadratic, well, the smallest Y value starts here, and it goes up to infinity. So the smallest Y value goes from 4 to infinity.